let's check and YouTube is ready or not. Okay. Yeah, I saw the live right now. Okay. Okay. So that today we have two topics we want to share. One is the I told you the house rule first. Because we will have two sessions. One is for recording and another one is an off record. For the recording, we will do something formal speech for sharing something, and then we will stream out the content in the YouTube channel. So please have to subscribe Open Source Hong Kong YouTube channel, because we want to make it 1,000 people and then do more configuration for our channel. And after the record session, we will go to off my party mode, and then we can casually share the any opinion or any technology you want to share, but don't want to make on record. So the topic is fine for long or short topic, like the Kafka Confluent have a session for 30 minutes for detailed technology related topic, or you have a small project want to share to find some people for collaborative. Still okay for hiring people. Anything you want to share is fine. Just you need to align is that this is the open source technology, so that you're welcome to do. If anyone want to share the topic on the fly in the event, please go to the HeadMD link and update any topic you want to share, so that I can update the rundown to for you those. So in today, I check in the HeadMD articles. We have two topics. One is the Kafka 101 and developing event streaming application with serverless Kafka from Kafka community, and then another topic is that Hong Kong address standardization library from HOA, so that we can start the Kafka one first. So I will introduce Simon Tam and Kenneth Zhang. They come from Confluent company. So can I pass to Simon or Kenneth?
Yeah,
Simon.
Thank you, Kelvin. Can hear me, right? So good evening, everyone. So my name is Simon Tam. Together with me, I have Kenneth Zhang here. We are both from Confluent, and Kenneth is our presenter for today Kafka sharing, and he is the solution engineer cover Greater China. We're so glad to meet you virtually this evening, and thank you so much for Open Source Hong Kong for the invitations, and hope our session still keep you awake after the whole day work. Before I pass it to Kenneth, maybe share the.
Maybe you can share first because you are the host. Maybe you
you share. Yeah.
Or Calvin, can you pass the host to me so I can share my screen?
Just a moment.
Thanks.
How to check? Just a moment. Keep the host. Reclaim the host, and then pass to Kenneth. Yeah, it's your turn. Yeah, it's okay.
Sure.
Yeah, thank you. So the second slide. So before I pass it to Kenneth, just a quick one to share why we are doing this sharing and why there are so many people talking about Apache Kafka. Today, software is the business. Software is the business. It's no doubt all enterprise are the software company, right? We are all transforming how to deliver better customer experience through software, how we interact and respond to our customer in real time. Most of the enterprise are now in the journey of the digital transformation. And the very hard for this transformation is the data. And more specifically is data in motion. Most of the time, fast data beats slow data in most of the use cases across industry, such that we should ask ourselves or our business team how they want to or what they need to consume and process data in the next project. With Kafka, a new data infrastructure to set data in motion, and it's the time to think how we unlock the value of streaming data. And what is the better option to adopt Kafka with time to market? And that is the topic today. Kenneth will walk through with you the cloud-native experience on Kafka. May I now pass it to Kenneth and hope you enjoy this evening sharing. Kenneth, please.
Thank you, Simon. Thank you, Calvin. So it's great to meet you guys all. First time we participate in open source Hong Kong community. So it's well, what Simon just mentioned is, the world has changed, right? I think in our working environment, in every day we are facing what we call everyone's doing digital transformation. So by transformation, what are we trying to transform? So that's one of the key points that we want to promote is to disrupt, our current infrastructure technology, which is, quite batch oriented, right? Everything based on batch processing, based around, and then now, I mean, everyday life, we are changing. Something like, for myself, I rarely go to the bank now. You go to the bank, you do banking, you do online banking. You order your grocery, you do online ordering, right? And you call a taxi, you just use the Uber app, right? So there's a big change in our technology world, right? So today's agenda, I'll first introduce Kafka 101, which is like the entry level to understand Kafka. For new joiner, just maybe the first time hear the word Apache Kafka, it's good to learn something new. But for old timers, it's good also to review, what Kafka underlying is, how it architect, right? And then a quick session on stream processing, and then the last thing that I'm going to show you a quick demo on the cloud, right? So our topic today is running Kafka like a serverless Kafka in like a managed environment, so we don't have to set up infrastructure. But before that, let's start diving in. So for today, I only have 30 minutes, right? So I try to fit in to 30 minutes. I can talk for 3 days, 10 days, because I talk Kafka, I get very excited. So I'll try to fit in the time. Yeah. So let me know if I really overrun too much. So just a bit of myself. My name is Kenneth Chung. I'm a staff solutions engineer. I was the first engineer in the APAC region for Confluent. And here's my email, my LinkedIn. So feel free to contact me. If you like what we're presenting today, if you have any questions, feel free. We just try to make a good networking so we can let more people understand what Apache Kafka is, which is in fact it's all around us. So a little bit of a history. There's a big keyword what we call data in motion, and by means of data in motion, we means real-time data, or near real-time. So some problems that some guys back in 2010, back in LinkedIn, who created Apache Kafka. And you might have heard of this word, Kafka. Apache Kafka has been used around the world right now, so, globally. Like many enterprises are having Kafka, like LinkedIn themselves. They were trying to tackle some of this batch processing. They want to move it to a near real time, or what we are trying to transform our enterprise nowadays. A lot of innovation use cases like real-time fraud detection, IoT, data analytics. And they had that vision like long time ago, like more than 10 years ago. So that was created from LinkedIn and then contributed to Apache community. And those guys are actually Confluent founders. They founded Confluent back in 2014. And then nowadays, if you look at the enterprise world, you see all these logos, they are all running Apache Kafka. So more than 80% of Fortune 100 companies, they're all running Kafka technologies. Like Netflix, if you watch a movie, I believe most of us do subscribe to Netflix, Disney Plus. They are all running Kafka technologies behind the scene or under the hood, right? So huge data volume, fast data. So I also worked in a big data technology a few years ago, and now I'm trying to promote what we call fast data now, right? And yeah, feel free to take a look at Apache Kafka, and let's dive into Kafka, right? So basic understanding of Kafka is it is a event streaming platform, and what underlying technology of Kafka, how it stores data is just like a log file. So we call it a distributed logs, right? So a log file, you can append new events or new message to the end of the log, and it's got Kafka is designed to collecting your data, ingesting to Kafka, process it in real time, store it. Okay, so the data get persistent into Kafka, and then you do a lot of data integration at scale. So to give you some big numbers, like Netflix is running Kafka like 6 petabytes of data on Kafka. And then something like Tencent, WeChat, they are running like 10 billions of message per day through Kafka. So that's very, very scalable technology, very proven, and then most of the enterprises are using Kafka. So that's why you will hear Kafka everywhere. Basically, when you go to work, talk to your friends, then you heard the name Kafka. And then this handsome guy is our CEO, Jay Krebs, who is the original creator, one of the creators of Apache Kafka back in LinkedIn. So 2010, he was working in LinkedIn as an engineer, developer. So I'm not going to play this video. I want to save two and 3 minutes just for my talk, a little bit of selfish, but you can always watch this on YouTube later on. I'll share the deck later on after the meeting, right? Oh, sorry. I skipped it. Well, accidentally. So Jay's just trying to introduce Kafka, but let me take the place tonight. And so only one slide I want you to take out from today's meeting. It's what is Kafka? What is the characteristics of Kafka? And a lot of people first talk to me, say, "Oh, Kafka is just a pipe," right? They all think Kafka is just like messaging technology, pub/sub technology. So a producer publish the data, and then the consumer consume the data. But indeed, you see the second characteristics, Kafka can store data. So Kafka will not dispose of data after you consume it. It can be persist in the pipe. So we keep the data in the pipe. There's a big reason for it is We want to process it on the fly in real time, and then we want to respond to these events in real time. So you can think of your new design of your application could be event-driven. Something happened like microservices. If you guys are in that space, Kafka is a very good fit as the backbone for microservices. So remember these three characteristics: PubSub, storage, and process on the stream. So by processing, we are talking about something like doing your ETL on the stream, on streaming data. Okay, a bit of Kafka. When we dissect Kafka at the bottom layer, it's all what we call Kafka topics. So when you produce a message into Kafka, it got, this is like a 3-partition scenario for a topic. A topic is like a water pipe, right? A pipeline. And these data get chopped up into partitions for performance, for parallelism, right? And then one topic gets chopped up into, like, for example, 3 partitions. This is going to increase, how we can, the speed to produce and the speed to consume the data. Kafka itself is a distributed technology, so there are multiple brokers that storing these data, these partitions. And then, very simple concept. You have a pipeline. You can ingest data, which what we call producing data, into Kafka, and then the data, the message itself got appended to the end of this topic. And on the other side, you can also have something called consumer to consume this data. And you can see there are multiple consumers who's consuming this data. The data, because of the data persistence, you can always ask, or program your consumer to go back in time to play this log again. So what we call replay capability. So Kafka itself is, you can persist the data. It's also immutable. So you can call it an immutable log, which is very good for use cases. You can go back in time. You can replay this data again and again if you want. And then Kafka has a very, I would say, production safe design, because it's made up of multiple brokers. When there is a partition get written into Kafka, it will be copied or what we call replicated into different brokers. So for example, there's partition 1 for topic 1. Once you write this data into broker 1, it will start replicating itself to the other brokers. So why do we do that? Because of high availability. And also we, in the Kafka design, is already very safe in mind to protect your data, to make copies of your data. So in case some of the brokers is down, you can still have copies of data within this cluster, right? So that's how we protect the data, keeping the peace of mind. These are all designed and built into Kafka, so don't worry about data loss if you configure Kafka properly, right? And then a little bit on the when Kafka can also maintain ordering of this message when you write into the topic, but there's a condition where you have to specify the key of the record or the message. If you see there's a you want all this data go into one partition, and one partition you can maintain this ordering of these messages, right? So if I keep on using the same key, it will go into the same partition. So you can maintain that order. So there's called straight ordering. Okay, so there is but as long as you specify key A, it will always go to the first partition, right? Key B, it will go to the second one, C and D, right? So there are today I'm just having like a high level, quick 101 session, but there are a lot of details, of course, so you can drill into to learn Kafka, right? And then to consume the data, on one side, producers producing data into Kafka, and on the other side, you want to consume, right? Good thing is Kafka has been great as decoupling your producer and consumer. So why is Kafka performance so great with high throughput scenarios? Because you can of course do multiple partition, and then you can produce data or consume data in parallel, and then also there are specific design of decoupling your consumer from your producer. So the production side, you don't have to worry about, okay, if I throw the ball to you, I don't care who is going to receive the ball. I only throw into Kafka Broker, where I can crazily ingest data, and then you as a consumer, you come consuming at your own pace, right? You can consume in real time. You can consume once per hour, depends on how you program your consumer application, right? And then consumers can be set up into different consumer groups, right? And also because of the parallelism, I want to have a higher performance consumption. I can add more consumers to the group. And if we look through into the consumer group, you can see there are 4 consumers in this group. And if they are all doing, helping each other to consume as fast as they can, so you have 0, 1, 2, and 3 consumers. And if there's one consumer down, then the workload will be shared to the remaining consumers in the group. So that's how we also maintain this, high availability as well as resilience and load balancing, all built into Kafka. So you don't have to worry about these. All you need is to create your consumer, consume which topic, right? And that's it. All right, so quick touch on the Kafka basics. Then I want to move into the stream processing topics, which is one of the keys characteristics of Kafka, right? By stream processing, I would give you a very simple example so you know what is stream processing, what is needed for a stream process application. So as you can see, there is an application in front of you. You can see this at what we call you know what it is, like an Uber app. Uber, Lyft in the US, they're all running Kafka under the hood. And this is a typical stream processing app or event streaming app, what we call. And there you can find these characteristics is, there is like massive data volume going through these applications, high throughput, maybe low latency as well, right? And there are 2 parts of this data. There are a lot of information going on in the screen, right? There's these car locations, the driver location, your location, so real-time moving dots, moving cars in the map, right? And this is what we call push queries. So we call it a push queries because it's pushing in, the driver locations, the position is changing, and even you are walking down the street, right? So that's the position is changing in every second and being pushed into this application. And at the same time, you also see something called what we call a pull queries, especially when you trying to call a cab. You have this experience, right? At different time in the day, you might receive a different price quote, right? Sometimes it's 2x when you try to call up a cab, a car in the peak hours, like when you're trying to rush to work, like rush hours, they give you two plus, right? you pay double the price. And how do they do that? This is like a point in time lookup, what we call pull. At this point in time, at the back end, it's there is data going through Kafka, and then this real-time data got being aggregated, being filtered, being enriched in real time. So imagine, I believe a lot of us has experience with ETL process, which we want to do some data cleansing, one daily report, right? You put all the data, the raw data throughout the day into a database, then you run it with the ETL tool, aggregate it like today's sales, like product sales, which product are the top sales. And these are the ETL process. And ETL process, now what we're trying to move it into the stream. So instead of waiting for our day to do the ETL, I want, give me the price right now. Give me the price right now due to, the weather condition, due to how many cars around me, all these different conditions, and give me the price at this moment in time. So this cannot be done by traditional database systems or batch ETL. It has to be streaming data, and then you do a stream processing. So a typical stream process architecture is like this, right? So you have, we call it, typically requires 3 to 5 distributed systems to make it work. So you can see all this logo. Maybe you are already experts in some of these systems, but in order to support this pull and push queries, and then also the stream processing, and then the data persistence, you need 3 to 5 distributed systems to do it. It's very complex, high operational burden. And then when you develop, your skill sets required, it's handling all these 5. One distributed systems like a big data, like Hadoop, is already, scratching head, and then you have 5 distributed systems, right? In order to simplify this, Confluent has come up with, a tool called KSQLDB. And after this meeting, you can even download KSQLDB and try, right, for free. I can show you some resources. You can learn KSQLDB and then try to start making some stream processing applications. With this, you only have 2 moving parts. One is Apache Kafka, and then KSQLDB. So 2 moving parts, you're done. And then the great part is you can handle this stream processing logic with SQL statements, right? This SQL is not traditional SQL like from Oracle SQL Server. It's what we call KSQL, right? It's a persistence. I'll show you in the demo quickly how it looks like, right? But it's greatly simplified the architecture, and with SQL for the logic, you simply develop and shorten your time to market, and maybe a few days with SQL background. You sit down, you just crunch out a few SQL statements, you're done, right? And with a stream processing application. So that's pretty amazing, right? So I'm going to show you something in the cloud, right? Kafka in the cloud. By serverless Kafka, I mean you don't have to set up. You just need to run on cloud with like a fully managed service available also from Confluent. And the scenario is like this, the use case. It's a simple Clickstream analysis. Again, remember, we are not doing batch analytics here. A typical use case right now, we try to do a lot of like Clickstream analysis with the page views from your website, from your mobile apps. You get this data ingested and then try to filter out. For my scenario here is first from the page view, identify, the end users. I want to pick out the women who is currently in the Clickstream, who's viewing my website, who is using my mobile apps and viewing a certain page. And then further filter from this group of women, I want to find the page views by region. Women who is viewing the page from, say, from Taiwan, right? And then maybe also another filtering is women who's living in region 8, and then women in the Clickstream who have viewed certain page, say page 2. And then a typical scenario would be, once you filter out this data in real time, you dump it into a cloud storage like S3, right? Okay, and I'm going to show you in the cloud environment. So this is the solution design. So I'll simulate these users data and page views data through CDC from database. So change data capture. So there are a lot of connectors which we can ingest data into Kafka. And through this CDC technology, whatever database you have, like traditional database, RDBMS, you can run this CDC and then keep ingesting any change to this data, any table you configured, and then it will be ingested into Kafka. And then we'll go through some KSQL to transform the data, to tweak it, to aggregate, to join, to filter, and then through Kafka connectors, we'll sync it to S3. So I'll switch to my demo environment. Just quickly log into Confluent Cloud. By the way, Confluent Cloud can be accessed. It's available in all major cloud providers, GCP, Azure, AWS, and it's available on Marketplace, or you can do a pay-as-you-go scenario. So you just swipe the card and start using it instead of building out your Kafka environments, right? So as I speak, I'll just go through this demo environment. So I've logged into Confluent Cloud. So underlying is all Kafka clusters. And you can see here is multiple environments. Maybe there's a production, developments, or your staging, but I'm going to go into my demo environment called GSKO. And then you can see in this environment, I have multiple clusters here already, because of time. Next time I can do a longer demo, but today I just show you, this cluster is running status. You can add clusters if you want. Adding clusters, you just don't have to build out your cluster, just provision it, just like cloud. Right? You can different types of clusters. Let me go back and I just go into this demo environment, which I just described the use case. So you already see some production and consumption of data, and then how much storage are being used up. And let me go into this cluster. So cluster overview, when we come into this screen, it's showing me, there are throughput, consumption throughput and production throughput. And also, if you want to better monitor your cluster, you can explore the different metrics, right? So you can export these metrics into some other tools like Datadog, New Relic, or Grafana, or ERK, Elastic, to do your own more monitoring. So it's very easy. You don't even know how many cluster nodes that we have set up, because we don't have this concept in the cloud, right? It's all set up provisions. All you need is provisions, and you don't really care. All I need is you support my throughput requirements, right? And then there are already multiple topics that's running in this environment. and you can see page views, right? For example, I click into page views, you can see there are something that's producing into this page view topic, and then some consumers are consuming data. And if I click on messages, you can see the real-time message that comes in to this topic, right? Offset is the location, the position where the consumer is consuming in the remember the partition, there's offset, consumer offset. So exactly you know which position you are reading, right? And how is my data get pumped into Kafka is I'm doing it through, if you today you want to build out a develop a Kafka client, you can just simply go a new client and choose your technology. You can build it with Java, you can do it with C++, Node.js or Spring Boot. If you click on Spring Boot, here it shows the code that generates it for you to access this cluster, the cloud cluster, and then generating your API keys and secrets to get a permission to access it, right? The data that generated from for the page views and users, the two databases, remember, through this data gen connectors. So these connectors, we have like 140 plus connectors available, and then most of them, now you can see in this environment, it's all fully managed connectors, so you just have to spin up and provision again, so you don't have to set up anything, right? And also on the sync side, so connectors, you have the source connector which ingests data into Kafka, and then you have the sync connector to sync it out of Kafka. And there's this S3 sync connectors. For example, if I click on S3 sync, you can see there's some throughput here. And then let's look at the configuration quickly. And yeah, so the data format that's being dumped into S3, we can specify it, and then specify some of these API keys and secrets to access, and then the S3 details, right? So if I also show you the KSQL DB, the processing part, which is most important. So we have one KSQL DB application called Stream App Transform here. If I click on it, on the right side, you already see we have some what we call streams and tables created in the stream, right, in here. And if you look more details, how is this data being transformed in real time? We have this something queries called persistent queries. And these are the KSQL statements. If you know SQL, you know what it means. Pretty much SQL. So, but this is not like a request response type of SQL. So remember, currently, if you want to do a real-time project, would you do fire your SQL like every minute to your database? I don't think your DBA would allow this, right? So this is different. It looks like SQL, it's got translated to streams applications. And these are not request response. It's like a passive queries running on active data. So you can think of this passive queries, which stays there like a net in the stream, and something get passed to this net, you catch it, right? You filter it through these SQLs. And so this is the KSQL applications, and you can also see the flow diagram, which we have the CDC from the users tables, page views, and get created in the stream. And then we have create stream operations. So you click on it, you can see all this KSQL running, doing the filtering and process the data and to catch female page views, and then 3 more for our downstream tables and streams. So all these are being processed in real time as the data flows through. And just show you quickly a diagram which is pretty much clear, how we start off with this data gen connectors, And you see this thick line is meaning the throughput is higher, more data, faster. And then from the user table get ingested and passing through this page view female KSQL queries, filter it, and you have this new topic called page views female. And then you further run 3 more queries, and then this data got passed through these queries and then land on a new topic. And at the end, with accomplished female readers, we sync the data through a connector. So this is like a very clear flow of this demo scenario. And all right, so I think I have pretty much overrun, and I just want to go through 2 more slides, right? One is if you're interested in learning about Apache Kafka, we have a lot of great ebooks free. You can go to download. Especially you want to learn Kafka, I recommend you to look into Definitive Guide. And also one of the latest book is Mastering Kafka Streams and KSQLDB. Or if you're interested in event-driven design, come look at these books. And the last slide I want to show, we have a one-stop shop. If you want to learn Kafka, come to this site, what we call Confluent developer site, and very nicely designed. And you can have from 101 basics to advanced topics. You do stream processing, and then I also suggest you can join also the Kafka meetups. So we do meetups regularly, and one of the audience in the list is Anna, who's running the meetups for us. And thank you, Anna, for arranging this opportunity with Open Source Hong Kong. And then if you want to try out the cloud, Confluent Cloud, you can also have a promo code, and then you can just try it with $400 promo code. I recommend you to get hands-on. And then if you are interested in further discussion, feel free to ask. So now I open up the stage, and we can do some Q&A. If you have any feedbacks, if you have any questions, feel free to ask. Thank you.
Any question to Kenneth? Thank you, Kenneth and Simon. Does anyone have a question? If no, I have a question first. Sorry, Kenneth.
Sure.
Can you hear me?
Yes. Yeah. Go ahead.
Yeah. So that can we as a consumer do we need to create a MQ to checking the order for the Kafka? Or we need a design for multi consumer, or I don't know in consumer side how to make the order for subscriber already put in the stream.
Yeah. So on one side, remember we have this technique with the producer. When they produce the data, if you want to guarantee the order, you specify the key, and it all goes into the same partition. And within the same partition, we maintain or guarantee the order. And from the consumer side, you don't have to worry about all these consumer joining or adding how many consumers to consume this partition. So one consumer is always consuming the same partition. So one partition would not be consumed by multiple consumers, but you can also group this into the same what we call consumer group, and they won't, they will keep maintain the order. And also, I heard you mention something like MQ or queuing technologies are what we call messaging technologies, which is comparing to Kafka is more like a legacy system. I know there are a lot. Everyone is raising hand. Hey, Kenneth, what are you talking about? Many of us in the banks, in insurance companies, we are using queuing technologies. Even open source, you use RabbitMQ, all these queuing technologies. But that is what I want to bring out, is the difference between Kafka and queuing technologies. Is the slide which I showed you the 3 characteristics of Kafka, and those are just pops up, right? MQ are just pops up. So you don't need another messaging to pass data into Kafka. All you need is a producer and consumer or connectors, right? We have a lot of connectors which help you to ingest into Kafka without any coding, right? Say we have Oracle CDC connector to produce data, and I can dump it to Hadoop, right? HDFS connector. And MQ or queuing technologies only supports the first part, like pops up. But Kafka is different. Kafka can persist the data, and you can process data in real time. And well, all you need is to build your consumers, right? And the ordering of this or coordinating the consumer group is all done automatically in Kafka.
Thank you. Does anyone have a question for it? No, I will not want one more question about it.
Sure.
Any best pattern for the event-driven design? For example, I just know maybe like a campaign engine, they are good to use the Kafka, but any other solution would advise to use Kafka for apply this technology?
Mm-hmm. You mean use cases, right? Typical use cases
right.
that fits, yeah. And it's very wide range, right? I want to go back into this diagram. You can look at a lot of these companies running Kafka. Well, as close as, something like, banks, many banks are running Kafka in large scale. And within banks, there are typically like mainframe offloading, like legacy mainframe. You lock up your data in mainframe, you process. If you want to process this data, it's very expensive, right? Costing to the bank. So a lot of banks want to offload this data into Kafka, pre-process the data, and then open it up, like a open platform, and for downstream access, like your new mobile apps, or some like NoSQL to store in NoSQL, then you leverage Kafka, right? And mainframe offloading, real-time fraud detection, like credit card swap, and you swipe your card. There, you can use stream processing to watch the Stripe order stream, and if you look at any credit card number, right, if happens to swipe 3 times, for example, within 5 minutes, I pick this events and put it in a different stream, and this stream is we already know this stream is, there are potential fraud stream or something wrong, right? So you can then send off to notify your user. So that's another typical use case for banks. And then for even in Macau, there are multiple casinos using Kafka technologies for the gaming systems. And then if you look at these, I think all the platform business, like digital natives, like Uber, you can also look at some of these like Airbnb, Netflix, some platform without physical assets, right? And these are like virtual banks. These are all running Kafka to support the use cases. But one of the key, of course, is the real time. If you mainly, I would, to put it simple understanding, using Kafka is for the use case where you want to respond to your customer in real time, increase the customer experience much better. You need Kafka technologies. You just cannot do it with traditional database. It's just not designed to do real time. Once you touch database, it becomes batch processing. Yeah, so I think later on we can also share a lot, if you're interested, we can share more of these use cases to you.
Okay, good. Anyone have a question, or if want to ask something privately, I think we can stay after who shared another topics, and then we off record we can discuss more.
Wayman
Is that okay? Can if
yeah, is it Wayman have one questions about?
Oh, Raymond. Hi, Raymond.
In the chat.
Okay, I saw it. If there's a use case that we need a job queue for some long running tasks, example for 1 hour, do you suggest to use Kafka? How would you suggest us to use for this case?
Yeah, long running tasks. By long running tasks, you mean you're processing the data just like what I described. Well, first of all, if I look at these questions, a job queue a queue is pretty much fit into Kafka, because Kafka itself is like a distributed log which is immutable, so it's a queue, right? And then if you say long running tasks, if you're meaning first part, you might be ingesting data, keep ingesting data. Of course, I mean that's a good fit. And also, if you want to process this data as they come in, that's also Kafka do the best job.
Raymond, is that okay?
Did I answer your questions, Raymond?
Yeah.
Or you can.
But like, can you hear me?
Good. Yeah.
Oh,
yeah,
yes.
It's better you speaking.
Yeah.
Because as I know that because Kafka, they have partitions, and once the events comes into a specific partitions, then they will just queue up in that specific partitions. So it will not reallocate after the after consumptions. So the event will not be reallocated to some other partitions. So for certain situations, if if 3 tasks are queuing up in the same partitions, but the other 2 partitions are empty, then for this case, we may not be able to fully utilize all our resources. So how could we deal with this case?
I see. It's a good question. I think it's down to how you design your partition. So there are multiple layers in Kafka. Not just there's like how you tune up your producers and consumers, and also how you design the partitions. If you say you have more consumers than the number of partitions, some consumers may be sleeping, not working, some are very busy, and then the partition, you might not only go to one partition, right? You have to design your topics into multiple partitions, and with the configuration of the message key, when you want to guarantee the ordering, then you configure the key so it only goes to certain partitions. But the key could be, could be account number, could be user ID. Then all these user from user 1, it will go to the one partition. User 2 will go to the second partition. So meaning there is no partition being free, but it all depends on how you design your partitions, the topics. And also the retention time. There are a lot of switches in Kafka you can tune. But first of all, every time we have to look in the actual use case and think of, how many partitions I need, and how do we ingest the data. for example.
Oh, yeah, thank you.
Thanks.
Yeah, I think it's good to know about like how we can design this partitions and consider about the number of consumers. Yeah, so I think that that's good to know. Yeah, thank you.
We can yeah, it's also good questions. I mean, definitely from your question, you are not first timer who yeah, there are some friends here might be first time knowing Kafka, some might be that's why when I talk to customers every day, there are different what we call maturity stage, right? So some might be just heard of Kafka, some might be already trying out, and I can share with you some of the you can go to Confluent blog to especially I can think of one blog that I can share with you, talk about partition design, and I think that one is also written by one of our founders long time ago. You know, it's a good question. It's also came out early on when Kafka just came out, and then one of our founders, Jun Rao, who wrote this blog, talk about how to design partitions.
Yep, sure. Thank you.
Thanks.
Okay, so a little bit overrun, so that I want to push another. Thank you, Kenneth.
Thanks.
And we want to share another topics from Hoa. He is a data scientist and active on the open data in Hong Kong. So that he has a topic called Hong Kong Address Standardization Library. So Hoa, is that okay for you to share? You feel sleepy already, and then you mute the mic. Can you?
Yeah. Okay. Thank you so much. So
please wait a moment. I want to share the host to you. Just a moment. How do I claim the account again? Just a moment. Oh, how do I claim the? Excuse me. Claim file. Oh yeah, here, and then run the host. Yes, you got the power.
Okay, yeah. And sorry, maybe let me find the slide. So let me check.
Unpin the account. Okay. Unpin.
Just 1 minute. Yeah, I just need to find the screen. Yeah, here we are. Yep. So yeah, so this is a very early project. I just want to kick off, by the way. So in case you don't know, so this is another open source project I have did over the last few last few days ago. So about how can we search the RAT kits like more efficiently, because since last few weeks ago, more and more people are going to get their test kits, but then most of them in the market will be only having the CE marking, which is like the CE logo, but not the HSC, which means the health standard committee, things like this. But then the latest standards will be more important than the CE marking. So that's why I made a fast search tool for them. Like, for example, if you type here like this, so then you can find the corresponding webkit kits, whether it is from the DOH or Department of Health from our Hong Kong, and then so is the EU standard, things like this. So yeah, so that's why I got so delayed. You can see that this is the project I want to I want to start with, then because of the COVID, and then things got pushed back, and then so yeah. But anyway, I really want to do this. So the idea of the project is really simple. So you can see that the question is really stupid. And then which is the first will be the CUHK really equal to Chinese University of Hong Kong. And so it's a similar question would be CUHK comma NT is really equal to Chinese University starting. So, and then the third question would be, is ICC equal to International Commerce Center? So, so from the like human or layman perspective, like it has to be equal, right? Because we all have, most of them will be here already, and then we at least we have heard the name. But then in reality, it may not be the case. Like think about if you just do the like super stupid or trivial approach, like doing the string matching. Of course, like in the computer sense, is not equal, even though they are in the same place. So how the story starts, because for some reason I need to deal with Hong Kong address like for so often, like since few years ago. So even before the COVID, I've been doing with the Hong Kong address. So, but then one of the API, which is of course is a good thing from the government, like which is the als.og or .gov.hk. So they have given us the free API. So for example, if you type the Chinese University, and then they were going to like do some data processing or look up in a database and then pass the things like in terms of district, street, building name, things like this. But then if you take in a closer look, like in what we are seeing in the screenshot, you can see that. So the first line you can see, which is a Chinese University in the XML address line, which is the request address. And then, but the suggested address will be quite far away. So one is in the Sartin, and then another one is actually the Chinese club building. So technically, it's nowhere in the new territories, right? So that's why. So this is one of the example of showing that the address lookup may not be so trivial, and then so really some more work or library on this. So similarly, if we do the ICC, so we all know that in Kowloon, but then again, it shows the ICAC instead. So again, so when typing address is especially by human entry, there would be some like typo, right? So this is a Whampoa Garden should be WHAMPOA instead. But then anyway, so if you have some minor typo here, you can see that wow, it is the Hong Kong Zoological Botanical Garden, which is again in Central or in the Amateur again. So it is from Kowloon to somewhere in the Hong Kong Island. So it doesn't make sense at all. But to be very honest, so yeah, just it's like a famous film and IT Gao is like 是但啦，反正我都冇 say. So that's why I come up with the initiative to trying to make a library by myself. So here is some suggested input. So we have, of course, it's like quite like simple, and then like not much detail here. But then here is trying to make from the program is like, for example, if you get the ICC, then eventually it is trying to return the International Commerce Center, and so is the this is I forgot where is it, but anyway, so Hanyan House and the Hanfuk Estate. So apart from telling the true like most similar address, it's also trying to break down the things into more granular details. For example, whether it has an estate entity, and also building entity and block entity and so on. But to be very honest, so yeah, my intention only would like show up and then just speak like very quick for a few minutes indeed. But anyway, so this is indeed somewhere I get the data from maybe from web scraping, maybe some other source like the Wikipedia, things like this. So at this stage, I'm still trying to gather some of the details of data in terms of like, for example, different street and then different street number. And so is the different district and with different building name. And then along with the district mapping somehow. And so is the another estate. You can see that Tuen Mun would be like Charlista Heights, and also maybe, wow, this is huge. And Yau Chin Wong would be in the post-piracy court. So things like this. So try to get some data at least, and then trying to do something make sense, like at least when I enter the CHK, is try to retell the Chinese University of Hong Kong. So apart from the scraped data from the data source and also some static CSV or JSON, then yeah, so here is a very quick demo. So if I type the typo here, so luckily it's trying to tell me the right address, which is the One Power Garden. And similarly, if I type the Grand Villa and then what return me something sort of in the current city, and then yeah, this one is really tricky. And then I finally on the internet, because when I was dealing with some COVID case, and then find out okay, some people will type the Sao Mau Peng DSQ, and then I just shocked. What does DSQ mean? And then it actually means that the discipline, the service quarters. And then wow, so well, if you do the same thing in the OGO, I don't know what will happen. I forgot, like it's actually trying to tell me okay, Sao Mau Peng is matched, but then is ancillary facilities, which I don't know whether it's true or not. Like yeah, so so that's why I want to build my own things to do the things like this. Yeah. So of course you may wonder, and then yeah, it is kind of like magical that you cannot keep all the acronym to the mapping like this way. It's not really practical, and then I don't have such that much time to do the data cleansing and things like this. So yeah, similar to this, like that's why the things is still in the development stage. So like Ho Xin Han engineering building, and then it just returned Zhao Yiqing engineering building, but at least it tried to return me CHK, Chinese University of Hong Kong, and when I type the CHK. So apart from the test data or like the CSV I have shown you in a few minutes ago, so I also have some, I also have some scrapper here. So you can see that from the code, you can tell that I'm trying to deal with 3 kinds of external websites. So one is the Wikipedia page. So if there is the entity or the name appear in the Wikipedia page, I try to do the web scraping and then analyze that, which district it is at, and also what is the official name apart from the short term or acronym of that particular building or area. So another one I rely on would be the Foursquare.com. So finally will be some property website. So that's trying to like slightly improve. But this I also tried to call the ALS or OGO API, but then just fail, and then it cannot do what I expect it to do. But so I'm pretty frustrated anyway. Yeah. So this is so far of the project. So yeah. So in the next stage, we're trying to really structuralize the whole program in terms of like a Python library. So ideally would be a standalone offline library, and then further extend to some web service. And yeah, so this is pretty much what I have done. Yeah, so yeah, so we finished. Yeah, this is super short. Yeah, catch up. Yeah.
Oh, thank you. How do we do the parsing for the address? Any trick for this?
So it's quite a few in this. So for example, of course, currently I still working on would be based on a comma. So if I speed up and different entity or different part of the string, and then I would just match the table in terms of maybe first district level or region level. So whether if I match the NT new territories, Kowloon or Hong Kong Island first. And then next I would do the parameterization on, like, for example, district within a region, like Sha Tin, Kowloon City, maybe Sai Kung, things like that, and then so on. So that's why you may find one thing is really annoying or ambiguous should be some building like would be having one single building only, while some place has been multiple building. Then that would be really tricky, but that I need to handle. And then the second thing would be if the thing is not in the database or in the internet, then it is it would be failed to be recognized. Like it cannot be recognized as any estate or building. But yeah, of course, most people think that makes sense because after all, it is not in any database. So yeah, but then sometimes imagine would be even a typo or even some building. So another approach I try to is whether it's possible to train name entity recognition model, so that whether it's a new kind of building or not, still it will have some sort of last resort or to do the parsing or like the standardization. Yeah, that's another approach. So, but yeah, this is a super early stage open source project.
Thank you.
Yeah.
And where can we access the Jupyter notebook?
Oh, I have not committed yet because it's super messy. I don't know if everyone's there or like if I commit that, absolutely some people will be angry. Like if I just throw the trash to the internet like this. So that's why I still need some time to do the refactoring. Yeah.
Big brother is
yeah,
okay.
Yeah.
Yeah. Okay, thank you. Anyone have question for this project or want to contribute or something, help Hoa to do something to boost the application? Yeah. Feel free to find Hoa directly. Yeah.
Does your project only support English? Does it support Chinese as well?
That's a good question. Yeah, ideally it has to be supporting at least for Hong Kong. It just should be either Cantonese or Chinese and English. But then at this stage, I would focus on the English address first. Yeah.
Yeah, it's pretty cool. Thanks.
Mm-hmm.
Okay, so thank you. I would like to off the record first, and then we can feature after the session, or maybe you can use the Chinese to ask the question after the streaming. Yeah. Excuse me. Okay, let me stop the record first. I would like to read in host and then off record. Yeah, so anything you want to share or any question, even English or Chinese for last two topic or something you want to share, feel free to ask in here. Yeah.